Good morning, my dear students. So, in chemistry, we are doing the fourth lesson, right? That is about transition metals and inner transition metals. So, transition metals are the D block metals. And these D block metals are called transition metals because they are present between S block and P block. They have transit properties from metal to non-metal, electropositive to electronegative. So far we have discussed about their place in the periodic table. Then after that, the electronic configuration, metallic property, atomic size, ionization energy, electrode potential, oxidation state, and catalytic activity, and magnetic properties, right? So these are the properties, characteristics that we have discussed. Today we are going to discuss about three more, right? After that, we are going to study about two compounds. One is potassium dichromate, the other one is potassium permanganate. Then the next half of the lesson is about inner transition elements. That's about F block. Okay. Now, the eighth property is the alloy formation. Right? Alloys are nothing but mending metal with other elements. So other elements in the sense, this is also mostly metal. So mixing one metal with another metal will result in the formation of a new composition or compound, and that's being called as alloys. Right? For example, how we make jewels. Right? Most of the ladies and even gents are wearing the jewels. For making the jewels, an alloy is definitely needed. What is that alloy? We need gold and copper. So when mix gold and copper together, it's an alloy. Using that alloy only you can make use of the jewels. Like that, alloy plays a very important role in the daily life. Not only in the domestic, even in the industry, we have this alloys playing a role, right? So, to form a very good alloy, we have the rules which are framed by Hume-Rothery, right? So, Hume-Rothery are the scientists who made certain rules for making a very effective alloys, right? The two metals which are involved in the formation of alloys must have their atomic radii, right, differing less than 15%, right? So the atomic radius difference between the two metals which are involved in the alloys must not be more than 15%. Then only they will be involving in the alloys. The second characteristic is that they must have same structural arrangement and same valency. And the valency must be same. Right? The valency, they must have same structure and same valency. Right? The third one, the electronegativity difference must be almost zero or must be very small. Then only these two metals can mix with each other, resulting in the formation of alloy. So these are the three rules which are framed to make an alloy, right? So their atomic radius difference must be less than 40%. Then they must have same structural arrangement and same valency. The third thing is their electronegativity difference must be almost zero or very small, right? So this type of alloys are very useful in our daily life, right? Mostly transition metals. Mix with each other to form alloy. So what is the reason mainly for that? Because the transition metals have almost same atomic radius, right? Their size is almost similar to each other. Therefore, one can displace the other very easily and result in the formation of the alloys, right? So we have gold copper alloy, we have iron alloys, we have copper alloys, tin alloys. Like that, we have number of alloys which are being formed in this. Even lead is also making alloys, right? So this is the knowledge that you should gain regarding the alloys. Almost all the transition metals are capable of forming the alloys. So alloy is nothing but mending one metal with another metal. For that, those two metals should have these three rules to be followed, right? One regarding atomic radius, then structure, then valency, then the electronegativity factor. These are the four factors which mostly decide about the formation of alloy, right? And the ninth one is, ninth property is formation of interstitial compounds. So transition metals have interstitial holes. So what is this interstitial? So in between one layer and the other layer, this is called interstitial layer. This is one lattice, this is another lattice. In between these two, there are some holes which are being developed in the transition metals, right? And these holes are filled easily by small atoms like hydrogen, carbon, nitrogen. So these are the smaller atoms which easily fill up the small holes in the interstitial holes, and they form a different type of compound, new type of compounds, and which are being called as the interstitial compounds. And mostly they are found to be non-stoichiometric in their nature. Non-stoichiometric means they do not follow regular percentage composition in the formation of their alloys. For example, we have titanium carbide being formed, and then there is zirconium hydride which is formed in this ratio, and after that we have this manganese nitride. So these are some of the interstitial compounds which are formed. The interstitial compound has got a lot of application, and due to their extraordinary properties, right? The first one is they are found to be very hard, right? The strength of the compound, the density of the compound, or the specific gravity of the compound increases, they form very hard compounds, right? And then the second thing is they have more melting point than the metals. So metals இருக்கிற melting point விட இன்னும் கொஞ்சம் ஜாஸ்தியா இருக்கு. மெட்டலுக்கு இருக்கிற ஹார்ட்னஸ் விட இந்த interstitial compounds உடைய ஹார்ட்னஸ் எப்படி இருக்குது? ஜாஸ்தியா இருக்கு. And the third one is particularly the transition metal hydrides. Metal hydrides are used as a strong reducing agent. Right? This is a major application. This is a very important application of this transition compounds. And the last one is the transition metal carbides are found to be chemically inert. They don't easily react. Therefore, electrodes and other electrolysis process, this chemically inert carbides will be used as the cathode and anode, right? And these are the main application of the interstitial compounds. So we should know how interstitial compounds are formed. Then what is the example for that? What is their extraordinary property? Then how they are improving the quality of the transition metals, and how it is having the industrial application. And the last property that we are going to see in this topic is formation of complexes, right? So complexes are nothing but coordination compounds. Right? So almost all the transition metals, they form coordination compounds. We are going to have a detailed study about these coordination compounds in lesson number 5. Lesson number 5 is completely about coordination compounds. The transition metals are small in size and they have large charge density in their nucleus. Because of that, they are capable of forming the coordination compounds. And apart from that, in the transition elements, in the d orbitals, there are empty orbitals which are capable of accepting pair of electrons from certain species. These particles or ions are called as ligands. This is a very important technical word used in chapter number 5. So ligands are the ions, maybe positive ions, negative ions, neutral molecules, which can donate a pair of electron to the central metal atom, transition metal, in the formation of coordination compounds. For example, we have iron with NH3 6 times, 2 plus, and we have cobalt, NH3 6 times, with 3 plus, right? Or even we have iron with Cl 6 4 minus. So these are all called complexes, or these are all called coordination compound ions. This is the central metal atom and this is the ligand. With the ligand, this gives electron and this takes electron. Therefore this can be called as Lewis base and this is called as Lewis acid also in chemistry, right? So number of coordination compounds are formed and these transition elements are known for the formation of the capacity of the complex compounds, right? So these are the 10 properties that you have to keep in your mind and you should have a knowledge about that. And in the tomorrow class we are going to start about the two compounds, particularly potassium dichromate and potassium permanganate. And after that we'll pass on to inner transition elements. So with this we wind up today's class. So from today and yesterday's class I will give the material also today. You go copy down the material and study properly for answering certain questions, right? Look back question also you can try to answer. If there is any difficulty you can post it in the WhatsApp group. Maybe next week onwards you can come and meet me to clarify your doubts in the school also, right? We are encouraging that from next Monday. Wednesday and Friday girl students can come and clarify their doubts, and Tuesday, Thursday, Friday boys can come and clarify their doubts, right? right? Not only chemistry, other teachers also will be available to help you, right? So that is the option given to the students as well as the parents to do better in studies, as we are definitely having public exam in the next 6 months. So let's keep going and do the studies very well. Okay, take care. God bless you.